Yeah, so currently simulator is launched and running just to save the time how to launch it. We have a car put in some on a road which is actually here nearby in Sunnyvale. This map is created from real 3D environment. It's in Borregas Avenue and Caribbean intersection. And currently the car is sending out sensor data to Autoware. Autoware currently is not using anything because I have not set it up yet. The first thing I'll do in Autoware, I'll give a 2D poses, which is basically to enable localization, and here car localized on the map. This is done with the LiDAR, so it's receiving LiDAR points. All these red lines here, those are coming from simulator points. And now I enable all the necessary modules. This one, and I can ask car to drive somewhere on the map, like here. Yeah, it calculated this blue path, and it should be moving. Yeah, this is Autoware controlling car. Simulator just receives control message: accelerate, brake, steer. So if I steer a bit away from the path it's following, yeah, oops, that's too much. Autoware fixes it and goes back on the road. So this is the basic way how we use simulator.
So you can make a noise.
Yeah, I can override basically car control, just manually steer and brake, or like I can stop the car. Well, Autoware really wants to drive, I cannot stop the car. So,
what about augmenting the sensor data that's being simulated? Like introducing noise as Showcase says.
So by noise event, I just input some steering.
What if you wanted to augment the perception data that is being simulated?
What do you mean by augment? What do you mean?
You're talking about just introducing sensor noise.
Oh,
exactly.
Yeah,
making it less accurate.
So sure, all the sensor data is in our control. We can inject whatever we want. So if I show the debug interface how it looks like for sensors, here we can see what currently sensors are attached to the car. Because it's simulated, we can attach many sensors here. I'll show you a bit later how it looks like. And if I visualize how LiDAR looks like, this is basically what LiDAR is capturing from the environment. So if you want to introduce no noise, we just modify these point positions however we want, and Autoware will receive all this data. I think this is currently 32 beam LiDAR. We can later switch to 128 to see how it looks like. So we have also camera, obviously. Here's the camera view. This is the image which is sent to Autoware. I think I haven't configured Autoware to use any perception, so it's kind of not using this information. But this is the image you will receive on ROS, and it's up to you to detect cars or some other things. Obviously, currently road was a bit empty, it was a bit boring. So if I just keyboard it, yeah. So if I enable, for example, NPCs, we have other cars obviously going around, and then the LiDAR is capturing all of them. So there should be points like, oh, oops. Sorry, it's hard to see maybe from this angle. So if I rotate the camera a bit. Yeah, we can see the LiDAR points are actually different. So this is a simulator if you run it from like A to B, like put a car and just send out the data and then see what's happening when you send back the control. We have different modes how to run simulator. So if I exit the simulation, and I start a bit different one, I think this one. We call it for data collection. This is the interface where we configure simulations. I won't go into more details here because that's a bit boring. But this gives you ability to choose which map to use, what vehicles to use, what sensors to put on the car. So here, for example, I have a car which is configured for like data collection. So if you're training your deep learning algorithms, you want a lot of data. So obviously we want main camera, which we saw already. We want LiDAR, which we saw already. But we also have ability. We also have depth camera. So this is just rendering depth view of what camera sees. Can I get this mouse? Sorry. Okay. This keyboard doesn't want to do it. So yeah. So we have a depth camera view. We have a semantic segmentation. So you get for free basically every pixel is segmented. Semantic meaning is assigned to every pixel, so you know exactly which pixel is road, which pixel is other cars, what is trees. We have 3D ground truths, so we have bounding boxes here on cars, so this is only visualization, but the same data is going over ROS messages. So you get exactly position, velocities, sizes of each obstacles, including pedestrians. We have also 2D ground truth, which is basically a camera image with rectangles and bounding boxes. And we have, that's currently what's configured. So these sensors you can position everywhere you want. You can face forward, face backwards, put up, put down. It's easily configurable and customizable. That's what simulation gives you. So not only we can customize sensors, we can also customize simulation in a way which would be hard to test if you, for example, want to test how your car behaves in the rain here in Silicon Valley. Obviously, rain doesn't happen much here, and if you are, let me turn off lighter. If you want to see how rain will look like for your sensors, here you can turn on some clouds. You can turn maybe time of day a bit later, add some rain, and make roads really wet, so there will be some puddles on the road. And this is like customizable as much as you want real time. No, I'm driving manually. I'm not connected to Autoware. That's basically our environment, and you can tweak it as much as you want. Get any kind of situations you want. So now car is driving without headlights. I think I can turn headlights on, and this is achieved by Unity's HDR3 rendering. It's very photorealistic as long as the materials are prepared with high kind of fidelity, and that's what we have done. This environment is created from real LiDAR and camera data captured on this road. So there was a car driving here, scanning environment, capturing images, and then we laid the geometry and the textures so it represents real world. Yes?
Can you do multi-camera simulation?
Yes. Yes. Well, currently I cannot configure it, but you can see these as two cameras. These are two separate cameras. So there's actually more cameras. Here's one more camera. Here are 4 cameras. Here is like actually 5th camera. Sorry, 4th camera. I can't count. So these are all real cameras. Currently it's configured to use semantic data and the depth data, but those can be color cameras.
Or what I mean from looking from a different angle.
Yeah. You can point to any directions they want.
So the sensor configuration is defined before you start the simulation, which is why Martins can't modify it right now, but the idea is that you can. And the computationally intensive part, which is actually rendering these, is the same as you would see here.
Can you launch more than one camera at the same time?
Yes.
Can you show the
way
way
for Apollo, then it has multiple cameras.
No, we could have no currently. Yeah, we have range. What we have also ability to put multiple cars on the road. So the Seago vehicle, which is currently 1, we have ability to put as many as you want. There is the menu here. I currently have 1, but you can put 4 vehicles in the same environment and see how they interact and behave when they see each other and drive next to each other. Yes.
So how difficult is it to create a new environment? How much time are you talking?
So it depends what you want. If you want a fake environment, like just not real world, there are companies who do that for you. They can generate like new environments just with a click of the button. If you want real environment, that's a question of time and money.
How much time? Weeks, months?
Months, but we are aiming for weeks. So that's another our business direction to provide the ability to create these environments. And we are working on a pipeline which will give the ability to do that in weeks. So you give us point cloud and camera images, and we'll create this kind of environment. We have done that. Actually, I can show different maps. So this was Borges Avenue, which is kind of road, just a road with a few intersections. We have different map for parking space. It's called autonomous stuff. It's also nearby, and it's meant for parking lot. So this is a map which has. So let's drop the car. And can you close down? Autoware wants to drive somewhere, and I cannot drive. just Control C. So yeah, this is a map which has more like a bunch of parking spaces. So if you want to test your parking algorithms, this is where you do. This was also created by scanning environment, capturing LiDAR point camera, and this was created, I don't know, 2 months, 3 months, or less, I don't remember. Something like that. A few months. I can put NPCs here, which And there are not many roads here, but a lot of parking spaces. Guy doesn't want to drive. So our NPC cars, they are kind of dumb. They don't have intelligence. They are meant only to be as a background actors to give you just data for obstacles or navigation, and they just follow annotated lines. Which is annotated. I was not looking. So they drive predefined paths. So yeah. How it compares? How can we choose Unity? So we choose Unity for multiple reasons. One is that it's easier to use for people who don't know any like 3D environments. Unreal is more like a coding environment where you need to write a lot of code for things to happen. Unity is more like a visual editor. You open it, you drag and drop some elements, you click some checkboxes, put some values, press play, and it runs. So it's easier to find developers who know Unity, and it's easier to, there is a huge asset store where you can download different assets. If you don't want to create real maps, you just download some buildings, put some medieval castles around, and you have like buildings around it. So that's very easy. Other reason, Unity is more friendlier or cheaper for license. So for Unity, as long as you use binary and you're not selling the product as a source code or something, you don't need to pay anything except the license to yourself. Unreal will take 15% of your revenue. That's if you are getting more revenue, the more you will pay to Unreal. Unity just is like $200 license per developer.
150.
100.
So how are we commercially selling this?
So yeah, this you can find on a GitHub, and you can download a binary build. We're planning to have a commercial product like based on that, and that will include basically making environments. If you're having a car, you ride the car somewhere, you share the data, we recreate the environment. Then the second thing, we plan to have a simulation in the cloud at scale. So if you're already past the moment where you have basically tested basic things, you want to multiply your test cases by a couple of millions, yeah, then you will need to have that thing in the cloud, and we will offer that thing in the cloud. And last thing is to basically make the resimulation. Many developers, we see that what they want to basically capture the situation from the real road and be able to run exactly the same thing, or with a few modification in the simulation. So if they have an environment where they have the situation, if they run it in the cloud, they will be able to run all the same things what they encountered on the real environment, but with permutations. But you can download this and run it with your AED software already right now.
So what is the recommended system?
Well, it depends. We see that many people who use perception, they want to collect the data, then they depend on the GPU. For the people who doesn't really care about perception, they just want to have the HD map and maybe test the planning or prediction. They don't need a really expensive kind of GPU. So it depends on the application. But yeah, right now we run it. What is exactly this?
1080 RTX.
Yeah, 20.
But if you have like a quad-core computer, like 3 gigahertz or so, and 1080 GPU, you can easily run one LiDAR, a few cameras, no problems.
Yeah.
If you want like have more LiDARs, 3-4 LiDARs, then you need more and powerful GPUs.
Yeah, so the main limitation here is actually your imagination, and it's mostly depending on how many sensors you have to run simultaneously. And you see that on this machine we support one LiDAR, I don't know, was it 64 or
This was 32.
32,
So, yeah.
plus like 4 video cameras, so it's more or less enough to simulate the basic configuration of the digital. But we're aware that many companies, they're having way more sophisticated configuration with 5 LiDARs, 8 cameras. For these things, we will offer the solution that will be later.
So you are running an RTX 2090.
Pardon?
You are using an RTX 2090 laptop.
This particular PC is running an RTX 2080.
Yeah.
But we are not using RTX features yet. We plan to. But
Yeah, we don't use RTX.
That's very new.
Yeah. Yeah, this is configuration for the sensor. It's a little bit messed up, but it's a JSON. So you can see all the parameters: the position of the sensor, if it's a LiDAR, number of the beams, what is the angle between the beams. You can mostly simulate any existing.
So what I did, I enabled 108 beams. That's how. Currently, I think there is something wrong with DPI. Well, it's real time. It's more than 60 frames per second. It's very quick. I think the DPI is a bit messed up here because the points are so big that we don't see points. We see big rectangles. But this is how 128 beam LiDAR looks like.
And the display there is 4K or?
This is 1080p.
1080p.
So we recommend to run 1080p because 4K is that's too much horsepower for rendering.
And actually, for many applications, the developer doesn't have to see this thing. Like, we know that it's very nice to see a beautiful picture, but in most of the cases, people actually look at RVs and see what is the output of the sensors. So for some cases,
I was most of the time running running simulation interactive mode. That means I can control car, I can control weather, I can do anything, can respawn the car in different position. Simulation supports multiple different modes. It supports Python API, where you connect with the street and control what's happening. Put a car, remove car, add other cars, start simulation, stop simulation. It supports headless mode, which doesn't render this view. That's meant for like automated testing. You want to just run script, go gather the data and stop everything. You don't care to see this, so that saves the performance a lot. So there are many different ways how to run. This is just most interesting to see because obviously it's interesting to see.
Are you currently writing data to ROS, or are you just running this in like a local mode, and then like how are you?
So right now, at this moment, it was just showing what sensor visualization happens inside the simulator. That's it. When we were before the first demo, we were running with Autoware. That was the real ROS data was coming over Ethernet cable to Autoware on this laptop. That includes images and LiDAR data, IMU, and GPS. We can do the same also with Apollo. Our simulator also supports Apollo 3.0, 3.5, and 5.0. So it supports all the default configurations of Apollo sensors. And in that case, there is no ROS, but there is a CyberRT framework to send the data. And we support also ROS2. So if you configure vehicle to send data over ROS2, it will produce messages in different format and send ROS2 messages, but there is no AD stack yet that supports ROS2. We are waiting for Apollo Auto, I guess. Sorry, Autoware.
These maps that you're loading for the simulator, are they from LG or can they be from various HD map vendors?
So the map itself, there are two pieces in the map. There is this visual environment and geometry, which is created by us. So that cannot be generated from HD map because HD map has only lanes, it doesn't have buildings. So that piece you need to somehow create it or generate, it's one thing. Other thing is HD map. That we support importing. We support importing all now from Lanelet. We are almost finished with Apollo importing, and I think OpenDrive is the next. That's one way how to do it. Other way is you have tools which allow to annotate the map. So if you have created 3D environment, you can actually, there's a debug interface where you can click the lanes and to write a lane. This is a lane, this is traffic light, this is stop line. And then you can export HD map to load into your AD stack.
Currently, the default environments and maps that we have are created by us. But the idea is that anyone will be able to build and publish the content in 3D environments. And we see a lot of our users are actually creating their own 3D environments and annotating them, as Martin said. Usually they have like a particular use case or area that they might want to do.
While drawing the HTML, all the objects required by Autoware is already implemented, like stop lines, like road surfaces and everything. Can you show an example on this, or?
So
it's in another environment.
Map annotation needs to happen inside of Unity Editor.
Right.
And here we're showing the actual binary, so it might be a little bit harder to show right now.
But you can go to.
It can be used by the third parties at the moment.
Yeah.
All the code is open. You can get it to run.
Yeah.
So if you want, go to our YouTube link. There are a bunch of videos showing what our simulator can do, and you'll see annotations how it's done.
Yeah, so the idea is that you take the code from the GitHub, and if you're a developer of the environments, of the content, you use the project from a GitHub, you make your own environment there. You put road. You can use any assets which are compatible with Unity. You can download them from assets store in Unity. You can use the tools like Roadrunner from Vector Zero. You can do anything, but as soon as it is seen from the Unity, you can click the button, which we have there, and it's part of the automation. You click the button and it produces you the file, and this file you can put anywhere, and then if you want to run the simulation, you add this environment by putting link to this file, which is published somewhere on
We
the
can
web
export
server.
those CSV files directly to
So
Autoware.
yes, exactly. So and this file will work with the same binary build of the simulator. Idea is that there is like usually 1 or 2 people in the company who are responsible for the content, and they mostly prepare all of the content, and then they build it as a bundles. And all other developers, they don't have to open a Unity. They don't do anything. They just put links to get those bundles and able to load them and use them in simulation. And that's applicable for the environment and for vehicles.
Normally, to be able to draw a quite good map, you will need like some CAD stuff like snapping and things like that.
Yeah.
So it's already supported.
We have a bunch of things that help.
So
like,
anything what
making
is
straight lines or making
Yeah, so
intersections.
SP line.
Yeah.
yeah.
You can
So
make the curves, you can extend, you can do more sampling on the curve.
yeah, right. So the idea is that visual things, the assets like the meshes, the textures, these things, it comes from the Unity side. HD map annotation, let's say that you either already have map or you want to make your own map. We have a tool which allows to import HD map into the simulator, and we use it mainly for NPCs, for other vehicles to understand where they should go. So, and another option to do your own annotation, and then you can export it in a format which is understood by Autoware or Apollo, and we support Plainlet 2, OpenDrive, Apollo, OpenDrive, and so on. So yeah, this way you use the simulator to create environment and even HD map.
So can you elaborate on how you use HTML right now? Supposing I have only HTML.
So if you only have HD map and you want to test the planning, you just open the Unity editor, you clone our project, you put a plane there, you can put anything on the plane, but then you can go in the menu and import your HD map, and that will make the annotation. And with this annotation, we will be able to run other vehicles kind of around. They will be able to follow HD map, they will follow the rules of the lights and so on. But obviously you won't have anything visually. For the visual, you need to use some other things to put it in the Unity asset store at your convenience. There have a lot of different environments.
Is it also possible to eventually export this
HD map you can also export, and that's basically the beauty. If you don't have HD map and you have a point cloud or some other thing, you put it in a simulator, you do annotation, and then you export it to your AED software, and you use exactly the same HD map which we use for other things like NPCs.
Scale, can you load like an entire city on there?
City, not yet. We don't have city yet. But we are creating larger and larger environments. This is like, I don't remember the size, but we are creating, I think, 12 times bigger map than this one.
Yeah, that's something that we're working on.
But we are talking to other companies, third parties, which will provide like kind of fake maps, like generated virtual environments. And those can be as large as you want because you don't need any like data processing to generate all the data. So we look at city scale maps probably at some point.
Can you simulate directional LiDAR, not the 360
Yeah.
LiDAR?
I mean, I cannot configure it right now, but we can limit angles and then sure it will be just pointing in one direction or something.
Yeah, so
This LiDAR is, all the source code is there, you can customize as much as you want. The basic functionality currently what it does is just rotates it. If you want to put it stationary, sure, it will be just stationary.
yeah, about the map, we welcome everybody to make the content and to use it and to share it. We have a plan to make the map of the San Francisco. Actually, in the old version of the simulator, we have a really big map. It was part of the San Francisco downtown, but because we had to migrate to a new rendering pipeline, then we didn't have time to migrate this environment, but hopefully we will migrate it as well. But everybody's welcome to make their own maps. We will make it very easy to build maps and to share them with the developers in your team.
So if you're wondering about collisions, we don't really care about what happens when car collides with a bus or something. I mean, if you collide with something, that's already too late. It's like your simulation failed. So we care about when you're driving, not when you're colliding. So we give this information to API so you can detect these situations. But the bus or other vehicles probably won't behave physically accurate when collision happens. So I can probably hit this bus and it will fly very far away. Something like that.
Yeah, but I can emphasize that actually for AD developers, the collision is usually not even like the failure. So usually the failure is happening before that, because it is super important to control the acceleration or the braking. So many things which we might not consider as a failure right now are actually failure. Like if your car has to make a turn at a high speed, it's a failure. If your car has to suddenly brake, it's a failure. So obviously collision is a failure. So it's like out of scope.
Are you using the Unity Pulse architecture for this, or is it still?
We are moving to that, yes.
Oh, moving to that.
Not yet. We are using some parts of it, like job system, to accelerate some parts of like LiDAR.
Okay.
But it's not fully ECS, so but we plan to do that.
Okay, that's cool.
That's how you get performance.
And can you remind us about action items or roadmaps? Like what's the most important features that you want to implement in the next phase, or phase after the next?
Our like feature roadmap, you mean? So as we mentioned, one of currently simulator is open source and it's free to use. The next step beyond this is really focused around scenarios and resimulation. So can you parameterize taking real world test drives or even drives that you have in simulation, expand it out to thousands of potential variations on this case, do it in simulation, and then scale this in the cloud. And that's kind of the direction that we are taking, kind of to bring more value towards continuous integration and really integrating into your whole stack.
What about the number of sensors and location? Like, I don't know now, it's configured to use one line on top of the
Yeah, so in terms of the actual simulator engine itself, there's several items that we're working on and are in the pipeline. One of the big ones is basically distributed simulation. As you can see, this is running on a single workstation right now, and the idea is, can we spread out and render one sensor on a single GPU or on a single workstation? That way you can actually spread out the workload among different workstations, and you'll be able to simulate a vehicle that's using more than 128 light hours.
So compromising performance, do you already have multiple sensor support?
Yeah, we do. But the question becomes, at what point is that not enough on a single workstation? For example, if you're using like 5 32 beam lidars with multiple cameras, full HD, that's when it kind of you start straining what the limits of maybe one workstation might be able to do.
And it is supposed to change the location of the sensors to be mounted.
Oh yeah, so that you might have seen in the web UI, we have the sensor configuration where currently you can specify it in a JSON format. The idea is we could potentially make this into a more user-friendly GUI where you can drag and drop things and it generates that file for you.
So do you have different models for sensors from different manufacturers, or do you use a generic?
So currently, most of the sensors that we have are pretty generic, and that's kind of one of our pitches, is as kind of this open and free to use tool, and well, one of the areas that we're partnering with is in content, where specific sensor manufacturers or people who need specific sensors with a very particular profile, including noise profiles, could be able to help us implement it and bring it in. As far as, if you have very specific needs already that and you know the specs of them, you can actually go in to the actual project and tweak them yourself, and get to kind of the fidelity that you're looking at.
Yeah, so existing, let's say the camera, it has a field of view, it has like far distance, the close distance, it has, I don't know, like 15 parameters in general, so you can more or less put those numbers which will be similar to your real sensor. If you're talking about really high fidelity sensor simulation, then it's usually the question of what are we exactly simulating in here, because we know so far that many of the manufacturers, they put a lot of things inside signal processing. So if you're not able to look inside the signal processing unit, you're not able to simulate it. And it's, I mean, what does it mean to be precise even? Yeah, I believe there should be some kind of a statistical number, what is the level of the noise. So all these things, it is possible to edit because it is open source. We don't focus on this right now because there are no particular company who's asking us to do that right now. But honestly saying, I suggest if you have a sensor, if you know the noise profile, if you know exactly how the noise should look like, just open the code, and it's usually just adding like a random to the output, and that's basically it. If anybody is working in a sensor company, please let us know. We're happy to collaborate. We believe that in the future, you won't be able to sell the sensor to the OEM unless you're providing the model for the sensor, just because in order for the OEM to validate their solution based on this sensor, they would have to run 1 billion miles. They cannot run 1 billion miles in the real world, so they will have to use the simulation, and they won't be able to buy the sensors from this company unless they provide these insights about noise patterns.
I think we're kind of running over. We'll be available for questions and whatnot, but otherwise we'll end it here. Thank you.